Welcome back to our channel Active Catalyst. In this video, you will understand the important question plus answer with concepts in Module 1. Welcome to DBMS Session 1. So first question that is normally asked is what is database and explain 3 schema architecture with diagram. So you already know database is nothing but it is the collection of related data with multiple instances. Right, so let us consider an example like employee will have multiple sub-related data, right, like EID, e-name, that is employee ID, employee name, employee age and e-salary. Now let us understand what is 3 schema architecture. So as it says 3 schema, we have 3 layers, that is external layer, conceptual layer and internal layer. Okay, we call it as external view because when the user, end users view from above, this is the only visible layer to the user. So it is external view which is connected to conceptual schema and internal schema. Internal schema is connected to database. So 3 schemas are there. So external schema is also called as view level, conceptual schema, and internal level is also called as physical schema. Now very simple explanation I've written, so if you find it easy you can study from this. External schema, it can be connected to front end, right? Front end means like the user is trying to find about database, whatever he sees will be front end, so it can be connected to front end. It is used for access control. It is used for access control. The information is retrieved from conceptual schema, means if user is requesting for some information, it is taken from whom? Conceptual schema. So the information is retrieved from conceptual schema. It provides one layer of security. Then next what we have is conceptual schema. So remember, only external schema is connected with front end, conceptual and internal schema is connected with backend. So that is why in conceptual schema you can see it is connected to backend. So it is derived from entity relation. So conceptual schema is referred as base table and it represents data model. So what does this conceptual schema contains? It contains all the details of physical storage. Like if you are looking from here, you can only find it from this layer, right? So similarly, if you are standing here and looking, you will be able to see only this layer. Similarly, and so on. Then we have physical or external schema where it represents again backend entity. Then we have what does this physical or external schema contains. It has the description of how the data is stored in the secondary memory, and it has a component called catalog. Catalog is nothing but it symbolizes metadata. Metadata means data. Like let me take an example. Suppose we have one folder. In one folder you'll have many files, right? So that is data for data. That is only metadata. Then we have a trick to remember for the second question, that is advantages of DBMS, which is asked for 8 marks. So just remember this trick. Ramu shares sweets in big ice cream events. Chintu is always carrying Didi. So R stands for redundancy control. Instead of reading this, I'll tell what it is. You understand and write it in your own words. So it will be fine. Redundancy means the data which gets repeated again and again. So in file storage, there may be the data which is getting repeated again and again. So that is not necessary, right, if it is present at once. So that other data or the duplicated data can be deleted. Next one is data sharing. So see here, you can see multiple users, right? So even if this person requests for one particular data and another person requests for same data, it can be accessed by both the users. That is data sharing. Then data security. So whatever DBMS is storing, it is accessible only to authorized users. Authorized users means legal users. Then data integrity. You already know about integrity constraints, right? Such as primary key, foreign key, which helps to maintain the accuracy and consistency of database. So D stands for redundancy, sharing, okay, data sharing. Then sweets, so sweets can be stolen by anyone, so you are providing security for the sweets. Then IN stands for integrity, B stands for backup, so that is why here it is backup and recovery. Then data independence, you already know what is logical data independence and physical data independence, right? So in simple, if I have to say, logical data independence is nothing but if you make any changes in the logical schema, it should not affect external schema. Physical data independence is nothing but if you make any changes in the physical schema, it should not affect conceptual schema. Okay, then seventh one, for that again you will see events. Events means efficiency. E stands for efficiency, so efficient data access. So we have queries, right? Through queries we can easily retrieve the data. Then concurrency control, you know what is concurrency control, right? Two things getting executed at the same time. Then data integration, so we can bring out many queries, many tables and combine it together, that is data integration. Then these three are extra, okay, 8 is enough actually, 9 I've written, these three you can learn in case if you forget. Then we have simple definitions like what is data dictionary, that is nothing but it is a centralized repository that stores, remember it like this, D, S and R, description, structure and rules about data. So what does this data dictionary contains is table name, column name, data type, relationship, constraints. So it acts like a catalog or reference book. So this much is enough for 2 marks. If you write only definition, they'll give you 1 mark. Okay. Then we have what is weak entity. That is very simple. Weak entity is the entity which does not have key attribute. So while writing the participation, always weak entity must be having total participation and they cannot be uniquely identified. So we need identity relationship. Okay, the next kind of question we have categories of data model. Again it is similar to this question only. How we have 3 layers, same explanation can be written here but little bit changes you have to make. So remember the trick as HRL, high level, which is also called as conceptual data model. Representational is also called as implementational data model. Low level is also called as physical. So already you know what is high level, which is easily understood by the end users, like how users perceives. So uses concepts such as what does conceptual use, entity, attributes, relationships, right? Then inside representational we have 4 types again. The first one is relational database model. So representation of database in terms of tables is relational database model. Now obviously table will consist of what? Rows and columns, right? So rows represent tuples and columns represent attribute. So these are rows, this is nothing but tuple 1, tuple 2 and this is called as attribute and this is the name of the relation. Then next step what we have is object oriented data model. So representing the data in the form of objects, that's it. Then network data model, representation of object data in the form of network. Okay, I have to just show it in the network format. Next one is graph or hierarchical data model, representing the data in the form of graph. But the disadvantage of graph or hierarchical data model is the node, each of the node will contain very less information and it is the low level, since it is low level, the data is stored in storage, that is explained in low level. Low level is nothing but your physical layer. Okay, very important questions like component modules of DBMS and interaction. By looking at this diagram, don't get scared, it is actually very easy. So I'll explain how to remember that. See here, D, C, A, P. Okay, D stands for DBA staff. So DBA staff can use either DDL statements or privileged commands. So DDL statements, when you have to run it, you have to send it to DDL compiler. After compiling, you get some data that is stored in our data dictionary or catalog. Okay. Then casual user. So normal user, what he can do, he can just interact with the queries, right? So query, then query has to be compiled, then the query needs to be optimized. Okay. Then application programmer, so they will be concentrating only on the application. So pre-compiler is required here. Then DML compiler, see here it is DDL compiler, here it is DML compiler. So pre-compiler is connected with the host language compiler. So there are multiple types, right? So SQL is one of the type of query language that we retrieve. There are some other languages as well. So the host language compiler is connected to compiled transaction, so that this entire compilation will happen here. The transaction will happen here. You know what is transaction, right? So all of this meet at a point. All these three meet at a point. So once they meet, what is meeting? You have to write that names here. Okay. So let us see what it is. Like this arrow you can see here, that is nothing but DBA commands. Then query is coming here, right? So queries are here, then this transactions is coming here. So transactions, so all three together you have to make this point. Then all these three things has to be processed. So runtime database processor. Runtime database processor is connected with stored data manager. Okay, remember this. Now this is just the processor. Whatever is processed, that must be stored. So that is why this layer is important. Now if I have told, right, two person is retrieving for same data, then we need concurrency control and backup. So this is the option. Now in the stored database, we can give out input or output from the database from data manager. Okay. Now like in explanation, what you have to write is each part, how it interacts with other parts. For that, how you can remember is, you already know what data dictionary is, right? So write that. That is like it contains information about the names of the files, the data item, constraints, relationship related data, everything. And this runtime database processor will run database commands, queries and transactions. Stored data manager will perform basic levels of maths, okay, basic computations that you can write. And you already know what is concurrency control, write it, okay, I've told it. Then later you have to explain about each of this. What explanation you have to write, you will understand while explaining the concept of end users. Okay. Next question is responsibility of database administrator and database designer. So first let us understand database designer. So let us assume we are the database designers. So we have to understand the user requirement and construct the appropriate database. So to verify whether it is correct or not, we can interact with other groups. By interaction, we will understand what is good and what is not good. So we can check its efficiency. Then database administrator is having main two roles, that is administering the primary resource to be database and secondary resource to be database management system and software. So he has to coordinate and monitor complete use of software, hardware resources. So he has to handle security and poor system response. So if any data is locked or if any hacking is happening here, database administrator will be responsible. Next question is types of end users with example. Okay, so for that you can remember like CNSSD. Casual end user. Casual means one who uses occasionally and do not have detailed information about its structure. He will be using occasionally, hence he will not have like detailed information about what is there in the database. So how does he retrieve data? He uses simple query language for data retrieval. Example, manager generating sales report. Then we have naive or parametric end users. So they frequently use, so they will have at least limited understanding about the data. Then example, you have to write bank attender checking customer transaction details. Then sophisticated. By hearing sophisticated, don't think that it is something nonsense. Actually it is good. They have good understanding about database and capabilities. They interact through complex queries. Example, data analyst. Then we have stand-alone. Alone means using alone. So for personal database will be maintained, like we use the apps like Microsoft Access and SQL Live. Example, you can write as a small business owner. Okay. Then system analyst and application programmer. So they design and implement and maintain the data. Example, software developers. Then sixth type what we have is database administrators. Whatever points you write here, right, same thing you can write here. Then we have characteristics of database, which is asked for 4 marks. We can remember it as characteristics. So SISS. So self-describing nature of database, insulation between program and data and abstraction. Then sharing of database and multi-user transaction processing. Then supporting. Okay, you share by supporting them. Support of multiple user views of data, like that you can remember. Then there is question like why mapping between schema levels are required, which is asked for 2 marks. Answer to remember, or trick to remember is DCIO. I am DCIO. Okay, IU or DC, like that you can remember. So D stands for data abstraction, C is consistency, I is integrity and flexibility, U is user specific view. Then we have types of attributes. To remember, there is a simple trick. You can just remember like simple, single and stored. So simple, single and stored, just write the opposite words of this. Okay, like simple opposite is complex, single multi-valued, stored just derived. Now you have to give on examples for each. Okay, first I'll show the symbols, later you can give the example of your own. So for simple, single and stored, it is just one O view. Okay, but composite is represented like this. Multi-valued is represented with 2 ovules. Derived is represented with dotted ovule. Then we have something like explain cardinality ratio and participation. So always remember, cardinality ratio is the maximum number of times an entity can participate in relationship. Participation is nothing but minimum number of times. Okay, same thing I have written, whether an entity can participate or not. So we have 3 types of cardinality ratio. 1:1, 1:n and n:n. So 1:1 means, this is an example that one employee can belong to one project. Okay, similarly 1:1. One teacher can teach multiple subjects. Similarly m:n, like multiple clubs can have multiple students can have joined into multiple club. Okay, then also they have asked to explain about the participation. So there are 2 types of participation, total and partial participation. So total is represented with equals to, and partial is represented with just one single line. Okay, then minimum, like total participation minimum value is 1, and in partial minimum value is 0. This is one example. This means total, this means partial. So partial may or may not participate, but total must participate. Then one more kind of question is logical and physical data dependence. Simple. Okay, we already know if ability to change conceptual schema without affecting external schema is logical, and ability to change physical schema without affecting conceptual schema is physical. So it is harder to archive and it is easier to archive. So it concentrates on the conceptual schema, and this concentrates on internal or physical schema. This is more complex and this is less complex. Then they have asked a few definitions I have discussed later. Now let us understand the importance of participation, role name and recursive relation. We already studied participation before. Now let us see what is role name. Role name and recursive relationship. Recursive relationship means the entity which refers to itself is called a recursive relationship. You might have heard recursive function in Java, Python and all. Same thing here, it is recursive relationship. So which calls the functions again and again as recursive relationship. So we have to represent it like this. So just give an relationship example which is referring to the same entity. Okay, it can be 1:1 or m:n. It cannot be like 1:1. Remember this. Okay, then we have ER diagram. So this is actually PYQ question where you can find it like about the company. They have told you to take employee, department and the project as strong entities. Project is here. Okay, so I've taken it to be strong entity. Strong entity is the one which has the primary key. So for department it is TID and here it is PN. So this is unique, so it is primary key. And dependent as weak entity. So they have told to take dependent as weak entity. So we have to refer back this to this only. Okay, because it is weak entity. See, also we have to represent the weak entity with double rectangle box. Okay, and just write the attributes, the cardinality ratio, minimum and maximum participation. I hope you know cardinality ratio for employee, it is written on opposite sides. Like multiple employees can belong to multiple departments, something like this. Constraints means you have to write the what you have imagined, like what rules you have applied for this diagram. Okay. File management and DBMS difference, very less asked question, but still you have to study. So it is having less security. DBMS has more security. Here we don't observe data redundancy. Here we have data redundancy. And here it is data is inconsistent. Here we can see data consistency. In file management we know the physical address, but here in DBMS we do not know the physical address. Here centralization is hard, here it is easy. We don't have structured storage in file management, but in DBMS we have structured storage. That is why we do query retrievals. Then there are some very simple definitions which you can see. Schemas. So schema is nothing but which provides blueprint or framework for organizing and understanding the database. Then we have degree of relationship. It indicates that number of entities that can participate in the relationship. Then data independence. You already know if we make any changes in one layer, it should not affect in other layer. What changes, we can access it, we can manipulate it. Okay. Then value sets. It is very simple. Like if you remember in second PU we had something called as domain and range. So within that range only it should be taken, the value is taken, right? So range of acceptable values that can be assigned to attribute within the database schema is value sets. Okay, so I have explained all the concepts of first model. If you need this notes, then I'm expecting for at least 50 likes. After I get 50 likes, I'll be adding this notes link in the description box. And if you need for the module 2, do comment.